Hi everyone, in the previous two parts we completed the front-end development. Today we are diving into the back-end of this project. We will be building the server-side features that make our application come to life. If you have not seen those parts yet, I highly recommend checking them out first. That will give the foundation for what we are about to do in this video. So let's get started. So I open VS Code and go to the terminal. Inside the backend directory, I'll create the backend server. So I navigate to the backend directory, cd backend, and initialize the app with npm init. Hit enter. The package name, let's say Medicare booking. Hit enter and continue. Author, and yes, this action creates our package.json file. As you can see, our package.json file is created with the name, version, description, etc. Next, I will install the required packages for this project. So npm install or I express for express framework. We need MongoDB and MongoDB database interaction. We need codes to handle codes origin issues, JSON Web Token for authentication, cookie parser for handling cookies, and .env to manage environment variables. Additionally, I need reactjs for password hashing. And make sure to install nodemon in your machine. I have already installed nodemon globally, so there is no need to install it again. However, if you have not installed nodemon, you should install first, okay? The installation might take some time. While we wait for the installation to complete, let's take a look at our schema. As you can see, this is our doctor schema. The doctor schema contains several fields. Let me explain what a schema is. A schema defines the structure of the data that will be stored for a doctor in the database. To put it in perspective, imagine you are filling out a form for a doctor. You need their email for contact purpose, password to secure their account, their name, and other important information, right? Okay, at the end of the schema, we have our model. So what is a model? Think of it like a blueprint when building a house. The schema serves as the design for storing doctor information. The model used to create, read, update, and delete the doctor, similar to placing furniture and decorating rooms in a house. Now let's the installation is done. So I'll go to the package.json file. Inside here, set the type to module to enable modular imports. So type, and it should be module. Additionally, add the following scripts. So first one is start node index.js, and the second one is start dev for development server. Nodemon index.js. By using nodemon, the nodejs application will automatically restart whenever you make changes. This saves you for manually stopping and creating the app every time you make a change. Okay, so now let's create our entry point in the index.js file. In this file, we will set up our server. So I'll create index.js. First, we have to import. So import express from express, then import cookie parser from cookie parser. The next one, import course from course, import mongoose from mongoose, import .env from env. So now let's create .env file and define our port. So port is equal to 5000. We will start using .env.config to load environment variables from the .env file. So .env.config and call the config function. Then we will create an app instance. So const app is equal to express. Then let's define our port is equal to process.env.port or 8000. For configuring course behavior, we will use the course option object. So const course options is equal to an object and setting origin to true. The origin true allows any domain to access the server's resources, which is helpful during development. In a production application, you would want to restrict the allowed origin more strictly. Okay. So now let's add a basic route to test our API. So app.get an endpoint response, request and response, and I just simply send response as a message. So let's just send API is working. To test the server, we have to listen the app, right? So app.listen. First parameter will be our port and the next one will be callback function. Inside this callback, I just simply console.log and server is running. Let's run the server. npm start dev. As you can see, our server is running on port 5000. You can then access the API endpoint by opening the root URL in your browser. So I just go to the browser and enter localhost 5000. As you can see that our API is working. Finally, we will use middleware. So app.use and express.json because we are going to parse JSON data. Then we have to use cookie parser. The next one is app.use and course. Inside this course, I have to pass the course option that we define at the top. Okay. Let's now connect our MongoDB database. So I'll go to the browser and search MongoDB Atlas. Click on this link and click on the sign in button. If you don't have an account, go to the sign up and create an account. After login, you will see an interface like this. Then click on this drop down and new project. Give a project name. Then click on next and create project. Then click on create. Select free trial and click on create. Once your cluster is ready, enter your username and password for the user. And click on create user. Then give the IP address. I just simply type in here 0.00.0 and click on add entry. Then finish and close. Now click on the connect button, then drivers, and copy the MongoDB URL and close. Now go to the .env file, create mongo URL variable with the MongoDB URI you copied, paste the copied link and replace the username and password. Okay, then go to the index.js file. Let's connect our database. So first we have to set strict query to false, otherwise it will warn the console. So I just write mongos.set and strict query set to false. Okay, now let's create our database connection function. So const connected db is equal to async and our function body. Inside this function I will write try and catch block mongoose.connect, and we have to pass the MongoDB URL. So the URL will be process.env.mongo URL and pass the options. Just copy the options and paste in here. Simply console.log MongoDB database is connected, and if I get any error, just simply console.log MongoDB database is connection failed. Okay, now we have to call this DB, right? Connected DB. So I just call it in app.listen. Okay, and now let's run. As you can see, MongoDB database is connected. If you get this message, that means your database is connected. If you get a database connection failed, that means your database is not connected. So make sure to connect it properly. Let's setting up controllers and routes. To start, we will organize our code. Create a folder named controllers and another named routes. Inside controllers, let's make an auth controller.js file. In here, we will handle the registration and login logic. So export const register is equal to async request and response, then function body. Inside the function, let's take a try and catch block. We will have a function to handle registration. We also create a similar function for user login. So I just renamed login. Now we need to connect these functions to specific URLs. In the routes folder, make an auth.js. Here we will import express from express, and we will import registration or register and logging function from auth controller.js file, and make sure to file extension is .js, otherwise it will throw an error. Let's get a router instance. So const router is equal to express.router, then router dot path will be register, and then our register function, similar for login. So why do we use post request here? Because when user register or login, they typically need to send sensitive information like password, email, etc. The post request send the data in the request body, which helps keep this sensitive data out of the URL and request logs, making it less likely for the data to be exposed or intercepted. So now let's use this route in our index.js file. So import auth route from routes and auth.js, and then use app.use /API /version1 /auth and then auth route. The line of code app.use /API /version1 /auth route is telling the application to use the auth route for any incoming HTTP request that match the /API /version1 /auth /register or /API /version1 auth /login. The router defined in the auth route will handle those requests, executing an appropriate function or middleware associated with those routes. Now we have to export router, so export default router and save the file. Now let's focus on registration. Destructure the data from request.body. So count something from request.body. So the kind of data will be obtained from request.body. If I go to our frontend and register, in here when someone registers, we will get their name, email, password, role, gender and photo. So let's destructure these pieces of data from request.body. Email, name, role, photo, gender. So now let's take a variable. Let user is equal to null. And we have to import user model from models, then user schema.js and doctor from model/doctor schema.js. We also need JSON web token, so import JWT from JSON web token and import bcrypt from bcrypt.js. Before creating a new user, we have to check if a user with the given email already exists or not in the database. So we need to find user based on the provided email. So if role is equal to patient, then user.find1 and assign the user variable. Else if role is equal to patient the if condition code checks the role value to determine if the user is registering as a patient or a doctor. It uses this rule to decide whether to interact with the user or doctor model in the database. Okay. Now let's check if a user with the provided email is found. So if user, then simply return the response. So return res.status 400.json message. Let's say user already exists. If no user is found, we will create a new user, but before creating we have to hash the provided password for security using the reactjs. Okay, so const salt is equal to await bcrypt dot gen salt or generate salt and pass the number 10. It generates a cryptographic salt. A salt is a random value that is combined with the password before hashing. The number 10 indicates the cost factor that determines the time taken to compute the hash. You can give higher values, but it will slow down the hashing process. Now we have to hash, so bcrypt.hash. The hash method takes two arguments. First one is our password and second one is generated salt. So now create a new user based on the role. So if role is equal to patient, user is equal to new user, and we'll pass the user information. Similar for doctor. So if role is equal to doctor, then new doctor. Okay, so this code will check if the role is equal to patient, that will create a new user inside the user model, and if the role is equal to doctor, it will create a user in the doctor model. Okay, so we created a new user. Now we have to save. So await user.save, and we have to send a response. So res.status 200.json success true, and message, let's say successfully created, user successfully created. And if we'll get any error, let's send a response. To test, I open Postman. By the way, you have to install Postman on your machine. So go to the browser and search Postman. We'll get Postman official website. They have a different operating system. Just install with your appropriate operating system. To back to the Postman, I'll create a collection called Medicare Booking. Now let's test our registration system. The request will post, and endpoint is localhost /5000/API/version/auth/register. Then go to body, click on a row and select JSON from the drop down, and let's give user information. So name, email, some random email, password, and role, let's say patient. Click on the send button. Okay, it's showing user already exists. This line is not an expected response. That means we have a small mistake in the code. So let's check the code. Okay, so here is the problem. I missed await because it's an async function and we have to await it. So await. Now try again. Click on send. As you can see, we get the response user is created. Now let's check in the database. So I go to the database and check in users collection because we give the rule is patient. As you can see, the user is created and saved in the database. Also user password is hashed. Let's now implement login system. We start by extracting the email field and password from the incoming request body. This is the user email address which they provide for authentication when logging. Inside try block, let's initialize a variable called user to null. This variable will later hold the user information if found. We perform two asynchronous queries to the database on two different collections. One is for patient and another is for doctor. We are looking for a user with the provided email in both collections. Now, if we find a patient with a given email, we assign the user variable to the patient. Similarly, if we find a doctor with the given email, we assign the user variable to the doctor. If no user is found, so check if user exists or not. So if not user, we send a JSON response. So return, I just copy and paste in here status 404 and message, let's say user not found. If user found, then we have to check if the provided password matches the hash password stored in the user object. So const is password match is equal to, let's comment first, compare password. Then we have to await bcrypt dot compare. The compare function takes two arguments. First one is provided password and second one is user password that stored in the database. So password and user dot password. If the password is not matched, we have sent the JSON response return. I just copy the status 400 and status false and message, let's say invalid credentials. If the password is matched, then we will generate an authentication token. So let's say get token const and we will call a generate token function. We did not create the generate token. Let's create. So const generate token that will receive user as a parameter and simply return JWT or JSON_token.sign. The first argument of JWT.sign is an object that contains the payload. In this case, we are indicating user's ID and role in the payload object. The second argument is the secret key used to sign in token. So we will get the secret key from .environment variable. Let's generate a token. So open new terminal. Node, hit enter. Then crypto.random bytes. Then 256.toString and give the base 64 as a string. Hit enter. Okay, it will generate a secret key. Just copy and paste in here. Remove the quotation. You don't need it. Okay, so now the third argument is an option object. Here we are setting the token expiration time to 15 days. You can give any of days you want. After that, we destructure the user object to extract certain field. So const something from user underscore. So password, role, appointments, while including the rest of the fields in the REST object. Finally, we send a JSON response with status 200, success false or true, success true, message successfully login. And we also pass the token, data, and role. If we get any error, then we have to send status 500 and message failed to login. Now go to the Postman and let's save the register endpoint for future use. Now we have to test our login functionality, so give the endpoint and it should log in. Go to the body, row and select JSON. Copy the provided email and password and remove name and role. Click on send. But there is a problem with login. We need to check the code. Let's make it capital letter. And let's take a look at our compare function. In the compare function, we destructure the password and passed in here, but I don't know why it's not work like this. So we have to pass the password like this. And remember to start the server, because we changed the .env file, and it should be requested body. Save the changes and try again. Click on send. Now it should work. As you can see, we get our response with our token, data, role, etc. Let's create another user and check if login it works. So I just simply modify in here. Email should be john@gmail.com. Name, let's say John. Password 1234. And click on send. User successfully created. Now login. Email and password. Click on send. It's all good now. And if I go to the database, as you can see, we have 2 patients in the user collection. Okay, let's dive into creating our user controller and routes. So inside the controllers, let's create a new file called user controller.js. We'll start by importing our user from user schema.js. Now let's write a function to update a user. So export const update user is equal to async request and response. This function will take the user ID from the request parameters. So const id is equal to request dot params dot id. And let's take a try and catch block. Inside a try block, we'll update their information with the data provided in the request.body. So const updated user is equal to await user dot find by id and update. Pass the user id and set the new value, set and requested body, and third parameter, set the new to true. The new true option ensures that we get the updated user information as a response. And now send the response. So res.status 200.json success true message successfully updated. And for error, let's copy this line and paste inside case block. Response dot status 500 success false message, let's say failed to update. Now just copy this function and paste it here 2 times. and it will delete user and user dot find by id and delete. Remove these lines. And message failed to delete, and this will get single user find by id message, let's say user found, data should be user and 404 no user found. Copy this function one more time, and this will get all user. And instead of specifying a specific user, we will simply pass an empty object that will find all the users from the user collection. Now for error message, let's say not found. Let's define our routes. So inside the routes directory, create a user.js file and import updated user from user controller.js, delete user, get all user and get single user. And we also need express, so import express from express. Now let's define our router. So const router is equal to express dot router, then router dot get then slash colon and id. This is a dynamic route for getting a user by id, and then our get single user function, just copy and it will just slash for getting all users, get all user, and for update user it will router.put and update user, and it will delete and delete user. And finally export default router. Now we need to use these routes in our main index.js file. So inside here import user route from route/user.js and use these routes. So app.use /api/version1/users and user route. Let's test our endpoints using Postman. So copy this URL and open a new tab, and which should be /api/version/user. Click on send. Oops, we get an error. It's look like I missed the .js extension in the user.js file. Let's fix that and try again. This time we get our response. But as you notice that we are sending sensitive data like password to the client, which is not ideal. We should exclude sensitive data before sending the response, right? So how we can do that? To do that, go to the user controller and here add .select and -password, which will exclude the password field. Okay, so try again. As you can see, there is no password in the response. Let's also apply this to the single user route. So just copy and dot select and hyphen password. To test, copy the user ID and open a new tab. Endpoint will be /user, then our user ID. Send a request, and now we have removed the password from the single user response. Now let's update a user, change the method to put, and let's update a role and set to doctor. Click on send. As you can see, the role is updated. Now let's switch to doctor controller. So copy all the code we have written for the user controller, create a doctor controller.js file and paste it here. Rename the user function and variable to work with doctors and import doctors from doctor schema. So I just select all Ctrl D, Ctrl D, Ctrl D and update all the username to doctor. Now let's create a doctor.js file inside routes directory. So doctor.js, copy this code and paste in here and rename all the user name to doctor. And use these routes in index.js file. Doctor route from /route/doctor.js and app.use/api/doctors and doctor route. And let's rename the doctor file name. Okay. Now test the doctor endpoint in Postman. Endpoint will be doctor and click on send. As you can see, we get an empty array because we don't have any doctors to the doctor collection. Let's create a doctor. So patient doctor and click on send. Now we have a doctor data. In the get all doctor function, we find all the doctors and return to the client, right? But in our front end, we want to implement a search functionality to filter doctors by name and specialization, right? If someone searches, then we want to show search result data on the same page. To do that, we will use query parameter from .query. So const query and request.query. This parameter is used to filter data based on specific criteria. Now declare a variable called doctor that will hold the retrieved doctor records. Then check if the query parameter exists. If it does, we'll query to find only approved doctor. So doctor.find is approved. If I go to the doctor schema, in here when someone registered as a doctor, by default it will pending and the admin manually checks and approves the doctor. Okay. Next, we will match either the name or specialization based on the provided query string. Or name, object and regex, query and options I. The OR operator allows us to find doctors that match either the name or specialization, and we use regex operator with the option set to I for case intensive searching, and same for specialization. If query parameter does not exist, we'll find all approved doctor and exclude the password. Now let's test this in Postman. Click on send. As you can see, we get an empty array because we don't have any approved doctors yet. But if we remove the condition and try again, now we get the data. Keep in mind that the doctor's status is pending, so we will need to approve them to retrieve their information. We'll implement this search functionality in our front when we integrate our API. Now we are moving into the crucial aspects of authentication and authorization. Before we dive into the code, let's understand the problem we are trying to solve. In Postman, let's update the role and click on send. Notice that we change the role field and update it without any checks. This means there is no authentication and anyone can modify user information. But in real application, each user should be able to update their own profile. For that, we need an authentication system to ensure that only the user who owns an account can access and modify their data. Similarly, in the context of admin dashboard, only authorized users should access certain routes or perform specific action. That's where authorization comes in. Let's start implementing this mechanism. Create a new directory called auth, and within it create a verified token.js file. Now let's import JSON.token from JSON.token and import doctor from doctor schema and user from user schema. Now let's define the authenticate function. So export const authenticate is equal to async. This function takes three parameters: request, response, and next. The next parameter is a function used to pass control to the next middleware. First, we will retrieve the token from authorization header in the request object. Const auth token is equal to request.headers.authorization. We expect a token in the format like bearer and then actual token. Then check if the token exists or not. If not auth token and not auth token dot starts with bearer. If it's not, it returns a JSON response with 401 status code. So return response.status 401.json success false message, let's say not token, authorization denied. Then try and catch block. Inside try block, we will verify the token. For now, let's log the token to see if it's work. Auth token. To actually use this authentication middleware, go to the user route and apply it to the single user route. Import authenticate from auth/verified token.js and use it in here. Now back in Postman, try to get a user with a specific ID. Click on send and you will notice there is a no token error because we haven't added it yet. To authenticate, now let's log in again. Copy the token, go to the authorization tab and select bearer token. And paste the token. Click on send and we get the response. To check if our token is working, let's take a look at the terminal. As you can see, our token with bearer. Now we need to extract the actual token value from this. Const token is equal to, we will split the token from bearer part to obtain the actual token value. Now let's verify. Const decoded is equal to JSON token dot verify and pass the token and process dot env dot secret key. The verify function decodes the token using a secret key. If the token is successfully verified, we extract the payload which contains the user ID and role. We add this to the request object so that subsequent middleware or route handlers can access this information. And call the next function, otherwise it will not work. If any error occurs during token verification, we enter the catch block and check if error.name is equal to token expired error. It means the token has expired. In our case, we set the token to expire in 15 days. Remember? So if it's expired, we return a JSON response with a 401 status code and message token is expired. If the error is not related to the token expiration, it's likely an invalid token, and we return JSON response with 401 and JSON success false and message invalid token. Now let's go back to Postman again, and this time try to access the user routes. As you can see, we can retrieve all the user because we are authenticated but we are not yet authorized. In other words, we want to protect this route and ensure that only the admin can access it. Let's implement this security measure. So export const restrict async and request response next. Inside the function, we'll start by extracting the user ID from the request object. It's important to note that this ID is assumed to have been added by a previous authentication middleware. Next, we'll declare a variable called user. We will find a user in both the user and doctor collection using retrieved user ID. This step helps us identify whether the user is a patient or a doctor, and the user variable will assign to the respective user document. Once we have the user, we will check if their role matches any of the roles specified in the roles array. So if not roles dot includes user dot roles, and this roles array is passed as a parameter to the function and making it a higher order function. So roles, and it's return another function. If the user role does not match any of the rules in the array, we'll return a JSON response with 401 status code and JSON success false and message you are not authorized. If the user role is authorized, we call the next function to pass control to the next middleware. Now let's use this restrict middleware. So import restrict from auth/verified token.js. After the authentication middleware, we will apply the restrict middleware and specify the role we want to restrict access to. In our case, we want only admin users to access this route. Let's test in Postman. As you can see, we now receive an unauthorized error because we are not an admin to access this route. To secure all routes, we will need to use both authentication and restrict middleware appropriately. By integrating these mechanisms into our application, we will ensure that only authorized users can access specific routes and perform actions. This added layer of security is crucial for protecting sensitive data and ensure that our application functions as intended. Now let's dive into implementing a review system in our application. To get started, create a new file called reviewcontroller.js, then import review from models/reviewschema.js and doctor from doctor schema. First, let's create the getAllReviews function. Export const getAllReviews is an async function, request and response. This function will be quite simple. We will pass an empty object to it which will instruct the system to find all the reviews in our database. So const reviews await review.find an empty object and we'll send a response. So res.status 200.json success true message successful data will be reviews. Copy this line and paste inside case block. Status will be 404 success false message not found. Next, let's create the create review function. Export const create review async request and response First, we will check if the request body contains a doctor field. If it does not, we will assign the doctor ID from the request parameters to the doctor field in the request body. So request body dot doctor is equal to request dot params dot doctor ID. This ensures that the review is associated with the correct doctor. We will do the same for the user, ensuring that we know which user is providing the review. Typically, it's the currently authenticated user. And we will get user ID from request. Once we have the necessary data, we will create a new review and save it to the database. New review, and we'll pass the request.body. Let's rename this. Const saved review await new review dot save. After saving the review, we will update our doctor document in the doctor collection. So await doctor dot find by ID and update request dot body dot doctor, and especially we will push the ID of the saved review into the reviews array of the doctor's document. So push reviews and saved review dot underscore ID. This way we can easily access and populate the review information for a specific doctor. It establishes a clear relationship between the doctor and their reviews. If everything goes well, we'll send a JSON response with a 200 status code back to the client to confirm that the review has been created successfully. So message review submitted. And for error, status will be 500 success false message error dot message. Now let's define the review route. Create a review.js file inside the routes directory and import express from express import get all reviews from controller / review controller.js and create review. Import authenticate from verify token.js and restrict. Now let's create router instance. So const router is equal to express.router and router.route path will / and dot get all reviews, and for create reviews it will be post and authenticate. For authentication restrict and export default router, and we need to use these routes inside our index.js file. So import review route from route/review.js, and we will use in here reviews and review route. One thing to notice in the review route is that the route is simply slash, but when we create a review, we need to associate it with a specific doctor, such as doctor/doctor ID /reviews, right? To achieve this, we will use a nested route. To set up this nesting, go to the doctor's route, import review router from review.js, and then router.useMiddleware function. This function configures a nested route. It tells our application to use the review router to handle routes that are prefixed with doctor ID/reviews. These structures ensure that all routes related to doctor reviews are nested under a specific doctor's ID, allowing us to associate reviews with specific doctors. However, in the review router, we currently don't have access to the doctor ID. To enable this access, we will use merge params true in the review router. This option ensures that parameters such as doctor ID from the parent's route are accessible in the nested routes handled by review router. Now let's create a review using Postman, but before creating, let's fetch doctors. Okay, we are encounter an issue where there are no approved doctors. Make sure to approve a doctor in MongoDB Atlas. Then update. Let's try again. Now we get doctor info. Copy the ID. Open a new tab, give the endpoint doctor/doctor ID/reviews. The method will be post, body, row, and select JSON. Review text. Go doctor and rating, let's say 5. Click on send. We are getting error, no token, so let's log in. Copy the token. Go to the authorization, select bearer token, paste the token, and try again. Click on send. Now we are getting our response and the review is created. And as you can see in the doctor document, we have our review ID. To enhance our review system, let's also populate the user information of the person who provided the review. This will allow us to display user details in our frontend. We can achieve this with a middleware function called review schema.pre. We can achieve this with a middleware function that executes before any query string with the prefix find. So this dot populate path will be user and user refers to this user inside review schema and select. We just need name and photo. This middleware function is used to populate user information in the review. It gets executed each time a query for reviews is made. By using the populate method, we fetch and add user information such as name and photo to the review document. And at the end, we need to call the next function. And we also populate in our doctor controller, so populate, and we want to populate reviews. Now let's create a new review. As you can see, our review is created. This is the complete implementation of our review system. Now when user provide reviews, we can associate them with specific doctors, and in our frontend, we'll have access to user details associated with each review. Let's now calculate average rating and total rating. To do that, we will use a useful method called statics in MongoDB. So review schema dot statics dot calculate average ratings is an async function. It will receive doctor ID as a parameter. For calculating average ratings and total, we will use MongoDB aggregation pipeline. So const stats is equal to await this dot aggregate. In here, this refers to the current review. So, what MongoDB aggregation pipeline is? The MongoDB aggregation pipeline is like a set of data processing steps for MongoDB databases. It lets you filter, group, sort, and transform your data to get the information you need. In the aggregate function, it first matches reviews associated with the specific doctor. So match and doctor ID. Then it groups the reviews based on the doctor's ID. So group object ID. Then it calculates the number of ratings using sum operator. Number of rating sum, and it also calculates average ratings using average operator. console.log stats to see the data. Okay, to see the data, we need to call the calculate average ratings. So review schema dot post save and function. Inside this function, they start constructor dot calculate average ratings, and we'll pass this dot doctor. The review schema dot post, it's a middleware function that part of the code is executed after a review document is saved. It calls the calculate average ratings method of the constructor model associated with the review schema. It passes the doctor value from the review document, which represents the doctor's ID, to the calculate average ratings for that doctor. To test, let's create a new review. Let's say a good experience. Click on send. Review is created. Now let's see in the console. As you can see, we get our state with number of ratings and average ratings. So now let's get another review, and this time rating 1 and review text. Click on send. Now as you can see, our average rating is decreased. Now we have to update the specific doctor document with the number of ratings and average ratings. So await doctor schema. We need to import doctor from doctor schema, and I just remove the schema. Okay, so doctor dot find by ID and update doctor ID, and we'll update total rating and average rating. Total rating, and we'll get the value from stats 0 index and dot number of rating and average rating stat index 0 dot average rating. Alright, that wraps up the development of our API for today. We have covered a lot of ground building various features like user management, doctor profiles, authentication and authorization, and even a review system. The only feature left on our checklist is booking, and that's something we will tackle at the end of this project. But before we bring this video to a close, I would love to hear your thoughts. Please share your opinions and feedback in the video description below. Your input is invaluable as it helps us to create content. And if you find this video helpful and informative, don't forget to hit that subscribe button, give a thumbs up, and share it with your fellow developers. Your support motivates us to continue creating content that empowers you on your coding journey. Thank you so much for joining us today. Stay tuned for the next part of this project.